Okay, welcome back to the another exciting session on electromagnetic fields. This is a second session on the electromagnetic fields, which is targeted for the SSC JE exam. Fine. Okay. Now let us focus on, as I mentioned earlier, this is a syllabus for the SSC JE. It is a very short and sweet. Electrostatics, magnetostatics, and time varying fields. Fine. Now what we'll do, here we'll focus on one more topic on the electrostatics, Gauss law. Number of times questions were noticed on that Gauss law. Fine. So let us have a look over the Gauss law. So before going into the Gauss law, you should know what is called the electric flux and electric flux density. Here the electric flux is represented with the symbol psi. Here the electric flux is represented with the symbol psi e. Units are coulombs. The flux units are also coulombs. Charge units are coulomb and electric flux units are also coulombs. Let me read out this statement what I have written. Later we will give the explanation. What is the statement I have given? Just read out. Electric flux, property of an electric field that may be thought of as a number of electric lines of force or electric field lines that intersect a given area. Okay, let me explain this one with the help of a diagram. Now let us take what is called a charge distribution. Here is a charge distribution. When I say charge distribution, it may be any charge. It could be a point charge, it could be a line charge, it could be a surface charge, or it could be a volume charge. Okay, what is the point charge? What are the units for the point charge here? Now, Q coulombs is a point charge. It is rho L coulomb per meter. It is a line charge. That means charge defined per unit meter. Fine. Or the rho S. It is a coulomb per meter square. Charge defined per meter square. And it is rho V. What is rho V? Coulomb per meter cube. So when I say charge distribution, it may have a point charge, it may have a line charge, it may have a surface charge, or it could be a volume charge also. So when you have a charge distribution, what is there around this one? There are some electric field lines around this. Electric field lines may be in a different direction, something like this, something like this, something like this, like this, like this, like this, like this, and like this. So these are the electric field lines. They may be of any direction, that depends on the nature of the charge, what is there inside this charge distribution. Okay friends, fine. Simple, there is a charge, around this charge there is a electric field lines are there. Now what I will do, I will consider some surface here. I will consider some surface here, the open surface I would say. This is a surface. So the electric field lines are present like this, and there is a surface I am placing here. Here is a surface. So the electric field lines are entering from here and leaving from here. You can see it. This is the open surface, something like a piece of a paper. It is the open surface. Okay, that means let me show you with the help of some example here. So the electric field lines are present like this. These are the electric field lines are like this. This is a surface. So the electric field lines are entering from this surface and leaving from this surface, are intersecting, or you can also say crossing. Okay, fine. Now, here is the electric field lines. Let me show you symbolically. Electric field lines are entering from here and leaving from here. Electric field lines are entering from here and leaving from here. Electric field lines are entering from here and leaving from here. Electric field lines are entering from here and leaving from here. Here is a story. Yes, so the electric field lines are entering to the surface and leaving from the other surface, other side. Entering from one side and leaving from the other side. Now read out here. Are intersecting, or you can also say crossing, or there is a flow. So these are the different words we have used. So the electric field lines are, here is a charge, here is a charge, this is a surface. The electric field lines are intersecting, or flow, or crossing the surface. Fine. Okay. Now read out this statement. What he has given? Electric flux. How do you understand the electric flux? Electric flux, property of an electric field that may be thought of as a number of electric lines of force or electric field lines that intersect a given area. So how many lines are intersecting with this given area is called flux. Or you can also say how many number of electric field lines are crossing this given surface is called electric flux. Okay. Or what is the amount of vector field crossing the given surface? What is the amount of electric field crossing the given surface is called flux. And what is the symbol for the flux? It is psi e, coulombs. Fine. Now we're going to introduce what is called a flux density. I'm going to turn the page here. Flux density, the next term is. What is the flux density? Or it is also called electric flux density. What is the flux density? Density means what? See, you can look at the option units here. So from units itself, if you remember the units properly, from the units itself you can decide some things. Okay. Sometimes there may be a questions directly on the units also. Fine. So now observe these units here, what it is saying. D coulomb per meter square. Now read out. A measure of strength of an electric field generated by a electric charge corresponding to the number of electric lines of force passing through the given area is called electric displacement. It is called displacement vector, or it is also called electric flux density. Let me go back here. So number of lines, what is the flux? I'll repeat again. Number of lines intersecting, number of electric field lines intersecting the given area is a electric flux, or number of lines crossing the given surface is called electric flux, or amount of vector field crossing the given surface is called electric flux. Now, what is this flux density? Suppose if you consider the small piece of area here. It is a dA, a differential area. Fine. Generally, we'll define the area direction as a normal direction from your mathematics. Fine. So I'll consider the normal direction in this manner. Okay. So this is a surface here. This is a surface and the normal direction is like this. This is a normal to the surface. Okay. From your mathematics, what is the area to the surface? The area to the surface is normal. Fine. Now, I'm going to introduce the new term, what is called a flux density. How it is defined? Flux crossing through unit area. Okay. Let us say the total flux crossing through this surface is a psi e. Fine. Let me turn the page here. So how this flux density is defined? D. The flux density, that is, you can read out number of electric lines of force passing through a given area. Fine. So how this D is defined? D is equal to d psi e by dA. Units are coulomb per meter square. Okay. Where, what is this dA? Where dA, differential area is equal to dA into n cap. Area direction is a normal direction. Okay, let me go back here. Fine. Okay. Now, this is a concept of the flux and flux density. So these are the essential two parameters, two things one should know in understanding what is called a Gauss law. Gauss law has got very good number of applications you will find in your day-to-day life. Fine. And even in the exam also, SSC JE exam also, number of times, and RRB JE also, in the state service exams also, number of times question was noticed on the Gauss law. So if you can understand this electric flux concept and electric flux density and dealing with the Gauss law is a very simple thing. Fine. Let me go back here. Now, before going into the Gauss law, let me give some idea of the Gauss law. What is the idea of the Gauss law here? Now observe here, let us say here is a charge distribution. When I say charge distribution, it can be anything. It can be a point charge, it can be a line charge, it can be a surface charge, or it can be a volume charge. It can be anything. So let us say this charge distribution is creating some 1000 lines. How many lines? 1000 lines are created by this charge distribution. Now I have placed some surface here. How many lines are crossing through this one? Let us say some 10 lines are crossing through this one. Whatever the flux you will calculate here, is that the total flux or part of flux? Only 10 lines are crossing. But what is charge is this charge is emanating is a 1000 lines, 1000 electric field lines. But here only 10 lines are crossing through this surface. As only 10 lines are crossing through this surface, whatever the flux you will calculate here, that is not the total flux. That is only the part of flux. Only 10 out of 1000. Fine. So I want to find out what is called a total flux, or you can also say net flux. So what kind of surface I should have? I should have a surface here, I should have a surface on the top, I should have a surface on the bottom, front side, back side, that side, this side, left side, right side, top, bottom, that side, this side, in all the sides I should have. I'll repeat again. 1000 lines are, let us for example, 1000 lines are created by this charge distribution. Only 10 lines are crossing through this one. So whatever the flux you will get here is only the part of the flux, not total flux. Okay. Suppose if you want to capture, if you want to evaluate the total flux, what I should do? I should place a surface here, top, bottom, front, back, that side, this side, isn't it, in all the sides. That means what kind of surface I should have? I should have a closed surface. And the charge must be inside. Okay. So this is so nicely given by what is called a Gauss law. Okay. Now this basics will going to put the foundation in understanding the Gauss law. Fine. Now let us see the formal definition of the Gauss law with this understanding. Here there is one relation. Before going into the Gauss law, you can focus. There is a relation between D and epsilon. Electric flux density is equal to electric field strength multiplied with the permittivity of the material through which the electric field extends. Okay. This is from the material properties. Just you need to remember this relation. This will going to help us later. What this is called? This is electric flux density. This is electric field intensity. Okay. Electric flux density, and that one is electric field intensity. Fine. Now this relation you must remember. Okay. Now let me go back here. Now we'll go to the formal definition for the Gauss law. Yes, here is the Gauss law. What the Gauss law is saying, just read out. The net electric flux coming out of any closed surface is equal to total charge enclosed by that surface. Fine. There are only 2 points need to be remembered from the Gauss law. Point number 1, the net electric flux coming out of any closed surface is equal to total charge enclosed by that surface. That is, psi E net is equal to total Q enclosed. So this is the In short, this is a definition form which you must remember. Psi net is equal to charge enclosed. That is, net electric flux is equal to charge enclosed. Let us try to understand what is the meaning of this with the help of some diagram. Okay, fine. Let me turn the page here. Now let me take some example here so that you will appreciate this. Now let us consider a closed surface, something like a balloon. It is something like a balloon. It is a closed surface, something like a classroom, something like a balloon. Okay, it is a closed one. Inside this one, it is a closed one, it is not a flat one. Let me put some dots here. Why I am putting this dot? To create the feel that it is a closed one. It is not a flat one, it is a closed one. Okay, I'll call this surface as a S0 surface. Okay, inside this one there are charges. What are the charges? Q1, Q2, Q3, Q4, Q5, dot 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 up to Qn. Outside this one there are charges. What are they? Q1 dash, Q2 dash, Q3 dash, Q4 dash, so on up to Qn dash. Okay friends, fine. Now according to the Gauss law, what Gauss law is saying is the net electric flux from any closed surface so the net electric flux, what Gauss law is saying, psi E net electric flux from S0 surface is equal to charge ENC. What is the charge enclosed? Enclosed means what? Charge which is inside that one. Okay, so what is the charge inside that one? It is Q1 plus Q2 plus Q3 plus Q4 up to Qn. So this is the charge which is enclosed by the S0 surface. Remember, the Gauss law talks about the net electric flux, net, which is equal to, you have to consider only the charge enclosed. Let us try to understand this one with the logic and intuition. Why you are considering only the charges which are inside? Why? Because it is talking about the net flux. So if you want to find out what is the net electric flux coming out of any closed surface, you need to consider only charges which are inside and you need to discard the charges which are outside. Okay. Now let us try to understand with the help of some logic. So let us say their charge Q1 dash is outside. Let us say it is creating some 3 lines, 3 electric field flux lines. So how many lines are entering? 3 lines are entering. How many lines are leaving? 3 lines are leaving. So entering and leaving are same. So what is net? Output minus input. Net is 0. Okay. Suppose if the charge is inside, let us say it is giving some 4 lines. How much is leaving? 4. How much is entering? Nothing is entering. 4 minus 0. There is a 4. Okay. So the net flux, observe here, the net flux will be contributed by the charge only which is inside the closed surface. If the charge is outside the closed surface, number of lines entering and leaving will be same. So the net flux is 0. Fine. Remember this point. Each and every charge will be associated with the flux lines. But the Gauss law talks about net flux. Okay. So for the net flux, you should consider only charges which are inside. Fine. Okay friends. Fine. Now what I will do, I will consider one more surface. S1 surface. This S1 surface encloses Q charges as well as Q dash charges. Okay friends, fine. Let us see. I want to find out what is the flux coming from the S1 surface. Okay, I will apply the Gauss law here. What is our Gauss law is saying? The net electric flux is equal to charge enclosed. S1 is equal to charge ENC, which is equal to, what is the charge enclosed by the S1 surface? You want to find out what is the net electric flux from the S1 surface. So what is the charge enclosed by this S1 surface? Q charges as well as Q dash charges. So which is equal to Q1 plus Q2 plus Q3, so on up to Qn, plus Q1 dash plus Q2 dash plus Q3 dash up to Qn dash. That is the story. Clear? Okay, fine. So this is all about the Gauss law. Let me reiterate here. What is the Gauss law? Just remember only 2 points. Net electric flux is equal to charge enclosed. You need to consider the charges which are only inside, and you need to discard the charges which are outside. Okay friends, fine. Now let us have some varieties of questions to appreciate these concepts. This is one of your previous question. Very simple question. Just you should know the concepts here. Charge Q is enclosed by the Gaussian spherical surface of radius r. If r is doubled, then the outward flux is. Yes? So let me show you with the help of diagrams here. What he is saying? There is a charge here Q. Now this is enclosed with the sphere. There is a charge here Q. This is enclosed with the sphere. It is not a circle, it is a sphere. Generally the closed surface what you are having here we have taken something like a balloon, that is called Gaussian surfaces. Okay, why? Because we are talking under the context of Gauss law. Okay, and this is a sphere, it is not a circle. So let me put some dots here to indicate that it is a sphere. And this is having a radius r. Let me call this as a S0 surface. So what is the net electric flux which is coming from the S0 surface? The net electric flux which is coming from the S0 surface is equal to charge enclosed ENC, which is equal to Q. Clear? Now let us consider one more case. So the charge, the flux coming, net flux is a charge enclosed, that is Q. Now if R is doubled, that means if the radius is doubled, is asking what is the new flux. Let me call this as a S1 surface. This is having a radius 2r. So what is the net electric flux? Charge enclosed. What is the charge enclosed by that one is a Q, same. Whether it is having a radius r or 2r doesn't matter. What is required is a charge enclosed. Instead of this one, suppose if you are having something like a box line kind of thing, what is the charge enclosed by that one is a Q. Same thing. So the charge enclosed is same in this case, in that case. So if the charge enclosed is same, the net flux will be same. Okay. So the shape of the Gaussian surface doesn't matter. Fine. So you can answer this one directly, but I have shown this one visually. Remains unaltered is the answer. Okay friends, let us have one more question. Here also same. The electric flux from a cube of side A is phi. What will be its value if the side of the cube is made 2a and the charge enclosed is made half? That is the thing. Charge enclosed is made half. So if it is made half, flux is also made half. Isn't it? Yes. Let me show you symbolically here. What is important is the size of the Gaussian surface doesn't matter. What is important is how much is the charge enclosed is. Okay. So if the charge enclosed is, you can directly write, no need to write all the things story. You can directly decide the answer here. what I know from the Gauss law is the net electric flux is equal to charge ENC, enclosed. Clear? So the electric flux from a cube of side A is a phi, and what will be the value if the side of the cube is made 2A and the charge enclosed is made half. So if the charge enclosed is Q, then the flux is phi, and this is having a side A. If the charge enclosed is halved, then what happens? Flux will also be halved. So with the side 2A. Whether you are having this much size or this much size, it doesn't matter. What matters is whether the charge is enclosed or not. In these two cases, charge is enclosed. Okay. So the dimension of the Gaussian surface doesn't matter. Okay. Only thing is charge must be enclosed. It must not be outside. If it is outside, you should not consider that. So for the charge enclosed Q, the flux is phi. If the charge enclosed is halved, flux is also halved. Fine. So what is the answer here? Option A is the answer. Let us have one more question. Here is a question. Yes. Three charges of 2 microcoulombs, 8 microcoulombs, minus 4 microcoulombs are located at 4, 8, 3, 2, 1, 3 and 4, 0, 1 respectively. Find the flux leaving the sphere of 6 meters radius. How much is that? 6 meters radius with center at origin. Okay, fine. Now observe here. Let me draw some rough diagram. I am not showing the coordinate system, just I am drawing some rough diagram. This is not a circle, it is a sphere. Let me put some dots here. If I put some dot here, it is understood that it is a sphere, it is not a circle. And this is having a radius. How much is the radius for this one? Here it is 6 meters. And there are charges here. Where those charges are there, I do not know. I'll check out. But 3 charges are there. I'll find out the length of these charges. If that length is less than 6 meters, then those charges are inside the sphere. Then you need to consider them. If that length is greater than 6, then those charges are outside the sphere. You need to discard them. Fine. So let me turn the page here. Let me continue here. So with respect to the origin here, what is this location? First charge location. Let me find out. What I know from the Gauss law is this law. Net electric flux is equal to charge enclosed ENC. Okay. Now let us find out the position of the first charge. What is the position of the first charge? R1 is equal to, you are finding the distance with respect to the origin. 4 minus 0 whole square plus 8 minus 0 whole square plus 3 minus 0 whole square. So obviously this is greater than 6. So you need to discard this charge. This charge is outside the sphere. Next, R2 is equal to square root of 2 minus 0 square plus 1 minus 0 square plus 3 minus 0 square is less than 6. You can check out this value. It is 4 plus 1 plus 9, less than 6. It is R3, next one. Square root of 4 minus 0 square plus 0 square plus 1 square. It is 16 plus 1, 17. So obviously this is less than 6. So first charge is outside the sphere. Second one and third charges are inside the sphere. Okay. So what is the net electric flux here? net electric flux is equal to charge enclosed. What is the charge enclosed? What is the charge inside? Second charge and third charge. What is the second charge? It is a second charge is 8 microcoulombs. Here it is 8 microcoulombs minus 4 microcoulombs, which is equal to 4 microcoulombs is a net electric flux which is coming out of that sphere. Okay, friends? Yes? Simple. You need to consider only the charges which are inside and you need to discard the charges which are outside. Let us take one more question. I have changed that question little bit here. Instead of center at the origin, I have considered the center at 2, 0, 1. Okay. 3 charges of 2 microcoulombs, 8 microcoulombs. 3 charges here, 2 microcoulombs, 8 microcoulombs. Let me add one more charge. It's missing. 4 microcoulombs are located at 4, 8, 3 and yes, are located at, just a second, one more point, are located at 4, 8, 3, 2, 0, 1, 2, 1, 3 respectively. Find the flux leaving the sphere of radius 4, 8, 3, 2, 0, 1, 2, 1, 3 respectively. Find the flux leaving the sphere of 6 meters radius with center at 2, 0, 1. In the previous question, what was the center? The center was at the origin. You have evaluated this distance with respect to the origin. Now you need to evaluate the distance with respect to that one, 2, 0, 1. Fine. Now let us take some rough diagram here. Here is a coordinate system. Here is a sphere. Let me put some dots here. And this is having a radius 6 meters. And there are 3 charges here. Where they are located, I do not know. Sorry. This is not at the center. The sphere is not at the center. Let me draw some diagram here. Sphere is not located at the center, somewhere here. The center of the sphere is at 2, 0, 1. Okay, fine. And what is the radius of this one? The radius of this one is 6 meters. Okay, and these are the 3 charges here. Number 1, number 2, number 3. Okay, now you need to find out the distance between these two things with respect to 2, 0, 1. What I know for Gauss law, from the Gauss law is the net electric flux. From the Gauss law we know that net electric flux is equal to charge enclosed, ENC. Okay, fine. So what is this R1 with respect to the origin? It is 4 minus 2, 4 minus 2, it is 2 square, plus 8 minus 0, it is 8 square, plus 3 minus 1, it is 2 square. So obviously it is greater than 6. Clear? The second one, R2, square root of 2 minus 2, it is 0, 0 minus 0, it is 0 square, 1 minus 1, it is 0 square, which is equal to 0. So obviously it is less than 6. R3 beta. What is this R3? Square root of 2 minus 2, it is 0 square, plus 1 minus 0, it is 1 square, plus 3 minus 1, it is 2 square. So it is less than 6. Clear? Now here, you have to discard this one. You need to consider this one and this one. Second one and third one. Okay? So what is the second charge and third charge? They are inside. Net electric flux is equal to charge E and C. Okay? So what is this is? This is second and third. That is 8 microcoulombs plus 4 microcoulombs, which is equal to 12 microcoulombs is the answer. Clear? Yes. So in the previous problem, that is was the sphere was located at the origin, but here the sphere is located at 2, 0, 1. Let us have one more question. The same thing was repeated. Okay. Something interesting. Looking similar but is different. 3 charges of 2 microcoulombs, 8 microcoulombs minus 4 microcoulombs are located at 4, 8, 3, 6, 0, 0 and 4, 0, 1. Find the flux leaving the sphere of 6 meters radius with center at the origin. What is the speciality of this question? Is it not a previous question? No. There is something different here. Let me draw some rough diagram here. Here is a sphere and having a radius how much? 6 meters. And there are 3 charges are there. Where they are located, I do not know. I need to find out their location. So what my Gauss law is saying, the net electric flux is equal to charge enclosed. So what is that Gauss law is saying? The net electric flux is equal to charge enclosed. What is the location of the first charge with respect to the origin, which is square root of 4 square plus 8 square plus 3 square, it is greater than 6. What is the second charge, R2, location of the second charge? R2 is equal to square root of 6 square plus 0 square plus 0 square, which is equal to 6. Array. In the previous questions, either you are getting greater than 6 or less than 6. Now it is equal to 6. That means charge is on the surface. Then what should I do? R3. What is R3? Square root of 4 square plus 0 square plus 1 square is less than 6. Undoubtedly, you need to discard this one. You need to consider this one. Then what should I do with this one? If the charge is present on the surface, what should I do? Let me show you with the help of a diagram here. Remember, one charge is inside, one charge is outside, one charge is on the surface. One charge is on the surface. Okay, if the charge is present exactly on the surface, what you have to do? It is something like this. Electric field lines are like this. This is how the things are happening. So some lines, you can treat this one as like this. Half of the charge, it is looking like half of the charge is inside and half of the charge is outside. Yes, so exactly because of the symmetry, what I can do, I can consider what is called half of the charge. If the charge is present exactly on the surface, you have to consider half of the charge. So come back here. So what is the net electric flux? The net electric flux is equal to charge enclosed, E and C. What is the charge enclosed? You have to take exactly this is on the surface. So you have to take half of this one, the second one. The second one is 8 micro divided by 2. The third one is minus 4 micro. 0 is the answer. Clear, friends? Okay, fine. Now let us take the applications of the Gauss law. So by using the Gauss law, you can find out the electric field. Let me show you in short like this. There is a mathematics integrals are involved here. We will not go into the details of that. We know that from the Gauss law, the net electric flux is equal to charge enclosed. Fine. So if the charge enclosed is 0, the net electric flux is 0, flux density is 0, electric field is 0. That is the story. If the charge enclosed is 0, flux density is 0, flux is 0, net flux density is 0, electric field is 0. This is a simple observation. From here, let us take some very interesting example. Yes. Now let us take what is called a perfect conductor. So here is a perfect conductor. At time t is equal to 0, I have placed some charges on the conductor. So as soon as you place the charges on the conductor, what happens? The charges are free inside the conductor, they will repel each other and they will come and sit on the surface of the conductor. Yes, so the charges will come and sit on the surface of the conductor like this. Charges will come and sit on the surface of the conductor. As soon as charges are free at the room temperature inside the conductor, charges are free. They can go wherever they like. They will repel each other. I have considered only the positive charges to make the explanation simple. So the charges will repel each other. As soon as you place the charges inside the conductor, they will repel each other and they will come and sit on the surface of the conductor. Okay? So the no charge will be there inside this conductor. So if you talk in terms of physics, the force exerted by this, all the forces will cancel out. Okay? Or I do not know anything about the physics. What I know is the Gauss law. I will apply the Gauss law here. I will consider the Gaussian surface just below this one. What is the charge enclosed? Charge enclosed is 0. Flux is 0. Flux density 0. Electric field is 0. So what is the electric field here? The electric field is 0. So inside the perfect conductor, the net electric field is 0 everywhere. Extremely important observation in your electrical engineering. Now I will consider the Gaussian surface here. Is there any charge enclosed? Yes, there is a charge enclosed. So there will be electric field. So the electric field is not equal to 0. And how does the electric field exist on the conductor? Normally, the electric field exists like this. So how does the electric field exist on the conductor? Normally. Okay, inside the perfect conductor, the net electric field is 0. It is a very popular statement. Okay, let us take one more example here. Hollow perfect conductor. It is something like your stainless steel lunch box. The lunch box, inside it is hollow. The charge is, I am considering, I am taking the cross section here. The charge is present only on the conductor. Clear? Now let us consider the Gaussian surface here, inside this one. Is there any charge enclosed? No. So what happens to the electric field? Inside the hollow conductor, the net electric field is 0. Suppose if I consider the Gaussian surface here, is there any charge enclosed? Yes. So what is the electric field? Electric field is not equal to 0. So on the conductor, how does the electric field exist? Normally outwards. This is the direction of the electric field. Okay, so how does the electric field exist on the conductor? Normally. Inside the conductor, electric field is 0. Inside the conductor, electric field is 0. Inside the hollow conductor also, electric field 0. You can check out this one. Take some stainless steel lunch box, place your cell phone inside that, close that one. Make sure that there should not be any air gap and call it from the other cell. You will get it as a no signal. Okay, so these are the extremely important observations. One is a perfect conductor, other one is a hollow conductor. In both cases, inside those things, electric field is 0. So let us conclude something here. Extremely important observations. First one, inside the perfect conductor, charges repel each other and tries to reside on the surface of it. Okay, so what is happening inside the perfect conductor? They'll come and sit on the surface of the conductor. The charges are distributed over the surface. So that can be treated as what is called a surface charge, which is characterized by surface charge rho s, coulomb per meter square. Next, point number 2. Inside the perfect conductor, the net electric field is 0 everywhere, isn't it? So inside the perfect conductor, the net electric field is 0 everywhere. Point number 2. Point number 3. The electric field on the surface of the perfect conductor is non-zero and exists in the normal direction. So on the perfect conductor, how the electric field is? Non-zero and it is in the normal direction. Next, last point. The electric field inside the hollow closed conducting surface is 0. Yes, so this thing. It is a hollow one, inside it is 0. It is called generally shielding, isn't it? Okay, fine. So now let us take some questions which are related to these applications of the Gauss law. Fine. So what is this was one of your previous question. The electric flux and field intensity inside the conducting sphere is. So what it is? It is 0. Inside the conducting sphere, the electric field is 0. Whether it is a hollow conductor or solid conductor, doesn't matter. Directly you can answer. It is 0 is the answer. Okay, fine. Let us have one more question. Fine. Inside a hollow spherical conductor, electric field is 0. Electric field is 0. Direct answer. Okay, fine. Now let us do some fast recapitulation here, what we have done in this session. Very simple concept, but important. Number of times questions was noticed in the SSC JE, RRB JE exams, and even in the state service exams. So we have started with some foundation to understand what is called a Gauss law. Fine. So to understand the Gauss law, some basics of electric flux and electric flux densities are required. What is the electric flux? This Gauss law is a part of your electrostatics. So what is the electric flux? Number of lines, electric field lines crossing the given surface or a flow or intersecting. Okay, different words are there, is called a flux. Fine. Now, I have introduced what is called a flux density. What is the flux density? Flux crossing through unit area. For the mathematical correctness, we have taken the area direction is in the normal direction. Okay, fine. Let us proceed further. There is a relation between D and E. D is equal to epsilon into E, where D is called electric flux density and E is called electric field intensity. You should always remember the units. Here it is, units are coulomb per meter square. Here it is These units are Newton per coulomb, or what is more popular is volt per meter. Okay, fine. Let us proceed further. Now we have defined formally what is called a Gauss law. What is the Gauss law? The net electric flux coming out of. Only 2 points you need to remember. Net electric flux is equal to charge enclosed. Okay, fine. That means you have to consider only charges which are inside. You need to discard the charges which are outside. Fine. Then these are the varieties of numericals, and interestingly, I have taken one question where I have intentionally considered the charge on the surface. If the charge is inside the closed surface, you have to consider that. If the charge is outside the closed surface, you need to discard that. Why? Because the net flux is contributed only by the charges which are inside the closed surface. Now, interestingly, I have taken one example where the charge happened to be existing on the exactly on the surface. So then what should I have to do? That means if the charge is exactly on the surface, yes, so here half of the charge is inside the sphere, half of the charge is outside. So you need to consider half of the charge. So 8 micro by 2 minus 4 micro, which is 0. Then we have seen some applications of the Gauss law without going into the much mathematics. Okay, so the net electric flux is equal to charge enclosed. If the charge enclosed is 0, net electric flux is 0, electric flux density is 0, electric field is 0. I'll be using this one. So it is a perfect conductor. So inside the perfect conductor at time t is equal to 0. Here this is at time t is equal to 0. As soon as you place the charges, they'll repel each other and they'll come and sit on the surface of the conductor. It is time t is equal to 0 plus. So the net electric field inside the perfect conductor is 0. The electric field will going to exist on the conductor, that too in the normal direction. Fine, let me turn the page here. So the net electric field is 0 even inside the hollow conductor. Perfect conductor, hollow conductor. Fine. Generally, this is called technically shielding. If you want to protect something from the electric field, what you have to do? You have to cover that one with a perfect conductor. So there won't be any electric field inside that. You can call this this is called shielding. Fine. So these are the conclusions we have drawn. What are they? I'll just reiterate. Inside the perfect conductor, charges repel each other and try to reside on the surface of it. So the charge on the perfect conductor is characterized by surface charge. Next, inside the perfect conductor, the net electric field is 0 everywhere. Next, third one, the electric field on the surface of the perfect conductor is non-zero, exists in normal direction. Last one, the electric field inside the hollow closed conductor surface is 0. Fine. So these are the extremely important topic. That is the reason why I have chosen this one. Number of times questions were noticed in SSC JE, RRB JE. Okay, even in other state service exams. You can easily handle with these kind of questions if you have a good concepts regarding this Gauss law. Okay, so this is all about the today's session. Hope you'll all going to make ACE online platform as a part of your success story. For more videos, subscribe to Gate Online app. Okay, good day.
It has helped me in my success.
Myself, Abhishek Kumar Sharma. I have scored All India Rank 1 in UPSC Engineering Services Examination 2021 in Electrical Engineering discipline. Now, I divide my preparation strategy into 3 basic things. The first thing is that you have to complete your syllabus from a basic standard source. The second thing is that you have to attempt previous year question. The third thing aspirant has to do is to solve as many test series as possible. I made 2 to 3 pages short notes of each and every subject. Now 2 to 3 pages short notes help in quick revision. If you keep working hard, you will definitely get success in this examination. This is what I followed, and I wish all the best for all the future aspirants. Thank you.
My name is Kuldeep. I have done my BTech from Ambedkar Institute of Technology, which is situated in Delhi, and I have secured All India Rank 1 in ESE 2021 from E&T branch. I took ACE Postal Course Mains Test Series and Interview Guidance Program in ESC 2020 and ESC 2021.
Hello everyone, my name is Karthikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program.
I am Vinit Kumar. I have secured All India Rank 1 in Mechanical Engineering in ESC 2021. I have been associated with ACE Engineering. I have taken various programs like Lives, main classes, Postal Study Course, Test Series and Interview Guidance Program. So would like to thank all the faculties of ACE. It has helped me in building my concepts and having my fundamentals cleared. I would also like to highlight that in Test Series, I have given various mock tests which have helped me in the time of real exam, and in Interview Guidance Program, building confidence in front of interview panel. It has helped me in my success.
Myself, Abhishek Kumar Sharma. I have scored All India Rank 1 in UPSC Engineering Services Examination 2021 in Electrical Engineering discipline. Now, I divide my preparation strategy into three basic things. The first thing is that you have to complete your syllabus from a basic standard source. The second thing is that you have to attempt previous year question. The third thing aspirant has to do is to solve as many test series as possible. I made 2 to 3 pages short notes of each and every subject. Now, 2 to 3 pages short notes help in quick revision. If you keep working hard, you will definitely get success in this examination. This is what I followed, and I wish all the best for all the future aspirants. Thank you.
My name is Kuldeep. I have done my BTech from Ambedkar Institute of Technology, which is situated in Delhi, and I have secured All India Rank 1 in ESC 2021 from E&T branch. I took ACE Postal Course Mains Test Series and Interview Guidance Program in ESC 2020 and ESC 2021.
Hello everyone, my name is Karthikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program.
I am Vinit Kumar. I have secured All India Rank 1 in Mechanical Engineering in ESC 2021. I have been associated with ACE Engineering. I have taken various programs like Lives, main classes, Postal Study Course, Test Series and Interview Guidance Program. So would like to thank all the faculties of ACE. It has helped me in building my concepts and having my fundamentals cleared. I would also like to highlight that in Test Series, I have given various mock tests which have helped me in the time of real exam, and in Interview Guidance Program, building confidence in front of interview panel. It has helped me in my success.
Myself, Abhishek Kumar Sharma. I have scored All India Rank 1 in UPSC Engineering Services Examination 2021 in Electrical Engineering discipline. Now, I divide my preparation strategy into three basic things. The first thing is that you have to complete your syllabus from a basic standard source. The second thing is that you have to attempt previous year question. The third thing aspirant has to do is to solve as many test series as possible. I made 2 to 3 pages short notes of each and every subject. Now, 2 to 3 pages short notes help in quick revision. If you keep working hard, you will definitely get success in this examination. This is what I followed, and I wish all the best for all the future aspirants. Thank you.
My name is Kuldeep. I have done my BTech from Ambedkar Institute of Technology, which is situated in Delhi, and I have secured All India Rank 1 in ESC 2021 from E&T branch. I took ACE Postal Course, Mains Test Series and Interview Guidance Program in ESC 2020 and ESC 2021.
Hello everyone, my name is Kartikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program.
I am Vinit Kumar. I have secured All India Rank 1 in Mechanical Engineering in ESC 2021. I have been associated with ACE Engineering. I have taken various programs like Life's main classes, Postal Study course, Test Series and Interview Guidance Program. So would like to thank all the faculties of ACE. It has helped me in building my concepts and having my fundamentals cleared. I would also like to highlight that in Test Series